We also have, and I just drove by of Camp Pendleton on the way here from San Diego. I do know Camp Pendleton has already a hydrogen filling station established where our servicemen will have the first exposure to this alternative fuel. I will tell you a little bit more about this as I give you a little bit an insight into the curriculum we have at Mira Costa. So the hydrogen highway plan. So, and certainly more and more in our time, and Peter Crabtree very nicely attached or touched down on the ecological issues, as he nicely showed with the Easter Island scenario. As you look, we have, and I don't want to ponder now in too much detail, we heard about this already, we have global average temperatures are rising, most likely due to these significant emissions of greenhouse gases, most importantly CO2, carbon dioxide. We have certainly a need for carbon neutral fuels and energy solutions if considering that the carbon dioxide as a greenhouse gas maybe and most likely according to whom you ask and which papers you read these days contributes to the global warming scenario. So we certainly have an incentive here from an ecological aspect. Not to mention we just survived, or at least domestically, we came out of the Deepwater Horizon issue in the Gulf of Mexico. Fossil fuel extraction, as we begin more and more to become aware, takes its toll, a tremendous toll on our diverse environments. Whether these are oil spills, whether these are oil shale fracturing, or I think we always stumble over that new terminology we hear from the natural gas field, and mountaintop mining. So we have certainly also ecological, environmental reasons to put into that equation if we want to commit ourselves in the future for biofuels production. So on top of that, most of us are aware that fossil fuel combustion in our traditional combustion engines, the Otto engine, diesel engine, turbines, release to some extent, and I tried to compile this a little particulate matter, diesel engines, NOx, ozone, Otto engines, gasoline itself, oil itself has traces of benzene, which is a known carcinogen, as we know. Heavy metals are released due to coal mining, coal combustion, and so forth. So why biofuels? Certainly several reasons to consider and put into that whole equation. So what are biofuels? So there's a very simple, and I pulled this out of the curriculum a little bit that makes it easier, what I taught last semester.
May I have your attention, please? May I have your attention, please? The cause of the alarm has been determined. No emergency exists. No emergency exists. We are attempting to reset the system. We apologize for any inconvenience.
That was a nice break to lubricate my voice a little bit. Good. So let's continue here and hopefully we'll familiarize ourselves with that voice. What are biofuels? You can quickly go over this and literally define it as any liquid or gaseous fuel produced from renewable biomass. Certainly also a term which is not clear to a lot of people what we talk about biomass in that broader sense. Certainly and I will show you then the curriculum I developed. We go in more detail with our students so they do understand from a good thorough basis what are different biomass components. If you take corn, we have starch, of course, as a key polysaccharide, which has been mentioned before, is already utilized in the United States to produce about I hope I have the correct number there. Certainly millions of gallons. I think it's about 3-4 millions of gallons of bioethanol. We have sugarcane in Brazil. Most of the bioethanol produced in that country derives from sugarcane fermentation. We have sugar beet. In Europe, in where I grew up, I do remember they had sugar beet operated bioethanol refineries established. Wood can, of course, be used, and that's one of the field. And I know from Biorad, we had a speaker here, and I unfortunately missed her. She talked about Biorad cellulosics enzyme kits, which of course are already offered for our students. Very important to teach it, to create the awareness. We have cellulose as a enormously important and abundant renewable biomass component, which we find in wood, in grass, in switchgrass, and so forth. There's tremendous interest currently in the industry, especially in San Diego. It was just in the headline with Diversa selling off there, or former Diversa, I should say, Verenium selling off their cellulosics department and R&D to BP, British Petroleum America. So there is enormous interest in the field. Canadian company Iogen is already heavily plowing the field of cellulosics enzymes and cellulosics fuels. We have biogas. It's one of the more traditional biofuels. We derive this from manure, from animal waste, which can then end up in gas fermenters and be converted into biogas and methane, basically. In Europe, mostly rapeseed, canola, they call it actually the rapeseed. Oils are used to produce biodiesel, or more and more these days, palm seed oil for biodiesel production, with, of course, all affiliated, and maybe in a discussion we can, of course, touch down on these issues if there's interest. And then, of course, diverse sugars, hemicellulosics, and so forth. They can be eventually in a future scenario utilized to generate biohydrogen. So many consider that many biofuels are produced with the help of microorganisms already. If you consider yeast and utilized for bioethanol production, a lot of bacteria produce the biogas in the biogas plants associated usually with landfills or wastewater treatment plants. We also have microbial enzymes, as I just mentioned, most importantly, the cellulases, where there's tremendous interest in the field. So I just summarized this portfolio a little bit. That's just an overview. It should show you how diverse, what a tremendous energy diversity you can develop, can be infrastructurally developed in the future, in also creating, of course, jobs down the road. And that brings us back to the agenda in here, in this forum, jobs for future generation. We have, as I mentioned, bioethanol, which can be generated currently with our current research and very well-established technology from all different kinds of resources, renewable biomass resources, biogas, as I mentioned, biohydrogen, and biodiesel. Now, why biofuels from microalgae? Now, that's always the big question people ask me. So why considering algae? What's wrong with biofuels from renewable biomass? Don't we have abundant corn? Don't we have abundant canola oil, palm tree plantations in parts of the world? Evidently not. There, it has been mentioned earlier, we have issues with competition with food supply in major parts of the world. People in Mexico and in parts of Asia were going already on the streets in order to express their concerns about rising food prices, as of course then more and more of the renewable biomass materials, as I just showed to you, are removed or utilized for biofuels production. So that's where a lot of people, including myself, believe that microalgae might come to the rescue here. So I tried to green this up a little bit here. Well, what are microalgae? The first question, and I'll show you a little bit the curriculum. I mean, it's an extract of the curriculum I somehow developed over the last pretty much last year, and introduced this. So students should know what are microalgae. It's a nice crossover into the world of microbiology, which is always nice for students, of course, to be exposed to microbiology. A lot of students love that subject. So we have microalgae, just an extension of a already existing curriculum with, more relevance to technology. So microalgae are microscopically small aqueous life forms which perform a process everyone knows pretty much from high school called photosynthesis. And what happens there is that water, well, certainly we will need water to grow algae, and carbon dioxide, as we heard earlier in several talks here, this greenhouse gas, which we abundantly emit into the atmosphere. So they will utilize it as carbon source together with sunlight and convert that into oxygen, which is a nice byproduct, but most importantly into what I mentioned earlier, the renewable biomass components. Most importantly, starch, oil, and cellulosics.